video kind of going over the test. So yeah, there were 73 possible. Now the way I do all of my tests is that at the bottom of each page is a circled number, the bottom right-hand corner, and that's the number you got right on that page. And so then what I do is I add up those little numbers. Every once in a while I will make a mistake. Okay, so you're going to want to kind of add up those numbers. And the way the tests go are kind of very similar to this one. You kind of have, I kind of mentioned the word crescendo if you're into music. I think my exams kind of crescendo into a forte at the end. So usually the end is where you get out your calculator and answer some questions. So this first few sections were about chemical and physical properties and changes. So I kind of said on the answer key, for a chemical property, then new substances are formed. For something physical, no new substances are formed. So the I was after chemical property with regard to rust. B, when anything changes its physical phase, it's a physical property. C, the fact that anything is a certain color, that's a physical property. D, density is also a physical property. And E, sodium metal reacts violently with water, that's a chemical property of sodium. The next section, A, was talking about sugar is turned into a powder sugar. And actually, the cute little sugar molecules have not been altered, so that's a physical change. For B, you can't undo a marshmallow, burning a marshmallow. Some people like them that way. So anyway, so that's a chemical change. C is a physical change, physical phase change. When water goes from a liquid to a vapor, that's a physical change. For D, carbon dioxide is produced when baking soda and vinegar are mixed together. The carbon dioxide gas is produced means it must be a chemical change. E, natural gas is combusted or burned in a furnace. That's an example of a chemical change.
What if you marked one wrong that was right?
Oh yeah, that happens too. If I mark one that was right, then definitely there'll be some time right after we're done here, and come by and show me, and I'll change it in the grade book. I'm sorry about that. Didn't do it on purpose. But yes. The next section throughout the semester, we're going to definitely round like we need to. And for multiplying or dividing, we round according to Sig Figs. So this was all about counting Sig Figs. So let me know if you have any questions. It's about the zeros. So in A, actually the fact that what usually gets people is that these two zeros are trailing zeros after the decimal. So they do count. For B, remember that this number's packed up in scientific notation, so we count Sig Figs in the coefficient. Yes?
Did we skip 3 and 4?
Yeah. We did? Oh, okay. Did I? 1, 2. Oh, man. They must have stuck together when I scanned in. Thank you. I thought that was a short test. Okay. I have my answer key right here. 3 and 4. Good job. So for 3, I'll just kind of hold it up here. For 3, this is a new test this semester. And so it's kind of fun coming up with these kind of little, like, beef stew and sadness. Of course, sadness is not matter, so it didn't actually fit in any of these. What I was after is you could pick out any of these, and I just wanted one. I wish my instructions would have been a little more clear on this. But so for the first one, an element, you could have either had helium or oxygen. And for a compound, you could have either had sucrose or table salt. For a homogeneous mixture, which reminds me, I need to fix my answer key that's posted to. I'll scan it again, no problem. C, for a homogeneous mixture, actually air and gasoline. Homogeneous means it's well mixed. For D, heterogeneous mixture, I would have taken beef stew or a hard-boiled egg. It's making me hungry. For E, a solid, I would have taken either a hard-boiled egg, sucrose, or table salt. And for F, a gas, air, helium, or oxygen. Thank you. So those were both 1 point apiece. For the next section was about the metric system. And so for A, what does the prefix centi mean? I was after 1/100th of the base unit. You could have put 1 over 100 or 0.01. Same thing. Centi. For B, mm means millimeters. There are exactly 1,000 millimeters in 1 meter. For C, what is the correct abbreviation for milliliters? Now, a lot of people put mm, that's millimeters. I was after milliliters, so it's m, lowercase m, capital L. For D, what's the relationship between a milliliter and a cubic centimeter? They're equal, so 1 milliliter is exactly equal to 1 centimeter cubed. For E, what's the correct relationship between meters and micrometers? And they are differ by, micro means 1 millionth of, and I prefer to put it this way. I prefer to say 1 meter is exactly equal to 1 million micrometers. Micrometers and microns are the same thing. For F, a correct relationship between grams and kilogram, that would be a factor of 1,000. And to say it correctly, 1 kilogram is equal exactly to 1,000 grams. Okay. So now on to this page, counting Sig Figs. So I think we did B. On to C. Now in C, this 0 is not significant. It's just a placeholder, but these 3 zeros between the 3 and the 6 are significant, so that gives us 5. For D, the fact that there's a decimal makes those 2 zeros significant, so that gives us 4 Sig Figs. For E, these 3 zeros right here are just placeholders, so we only have 2 significant figures there. And for F, this 0 is significant because it's between 2 non-zero digits, and this 0 is significant because it's a trailing 0 after the decimal. There are 6 there. Okay, so in this one, each worth a point apiece, you had to do 2 things. You had to pack it up in scientific notation and round the coefficient to 4 Sig Figs. So both of those things. Did you guys like, because I did you like the kind of the little, when we did our review session before your test, kind of having a pre-test sort of? Yeah, I thought that was fun. We'll probably keep that up. So you can let me know if you have any questions about how I did this, but I think they're all right. Okay. The thing about C is that actually if you have a negative number, the negative sign is still associated with the coefficient, and then the exponent of 10 is positive in this case. So there's that one. On to, we're crescendoing. Okay, so 7A, what I wanted you to do was to add up those 3 distances. And good job. I'm kind of liking what I see. You're showing all of your work. That's very good. That's most appreciated. That's all good. Since we're adding, we round according to decimals. So I put check marks over, we have 3 decimals in the first term, 2, and then 1 decimal. So we're only limited, or we can only report 1 decimal. So reporting 1 decimal, it's 13.0 kilometers. The next one was to give me the volume of that block given those 3 unique dimensions. So of course volume is we're going to multiply those 3 dimensions together. Now since we're multiplying, we round according to significant figures. And so it looks like we have 4 Sig Figs, 2 Sig Figs, and 3 Sig Figs. So we have to round according to 2 Sig Figs, and so the answer is 41 centimeters cubed. Again, keep up the good work showing all of your work. Okay, there's this thing called partial credit. So of course these are worth 3 points apiece. Partial credit saved my butt in college a lot of times. So, all right. The next one then, we're crescendoing, right? So if you read this a few times, and sometimes you have to read it a few times, it gives you some weights and it gives you a volume. It describes an empty graduated cylinder. It gives you the mass of the empty graduated cylinder. And then it says that, that we put in 24.5 milliliters of liquid, and they weighed it back again. Of course, it increased the mass. And you're supposed to come up with the density of the liquid. So density is grams divided by milliliters, or mass divided by volume. So we can get the mass by difference, okay, and we can get the volume's given. So we just take that mass divided by that volume, and voila, we have 3 Sig Figs. We round it to 3 Sig Figs. Okay, so don't forget, and again, you're showing your work, which is great, to include the units in your work as you go. And that would kind of make things fall into place. So the last one on this page says we've got 3 gases. We've got helium, He, neon, Ne, and argon, Ar. So here are the masses of those 3 gases. Pictures sometimes are really kind of nice with working problems. So you don't need them, I don't need them, I don't know. But so the total mass of the gas is 44.67 grams. And we're supposed to come up with the mass percent of neon. So of course, once we have that total, all we got to do is take the mass of neon, which is 14.73 grams, divided by the total mass, 44.86 grams. You know, this whole drawing stuff is kind of like, you're like, I don't need to do that. But if you do it like this, then you can go right to the mass of neon. Because sometimes, if you're like me, there's just too many numbers and too many words. But a drawing makes a lot more sense to me. So, on to, is it the last page? Nope, 2 more pages. Okay, so for this one, it says, what is the mass of carbon tetrachloride? It gives the volume of the carbon tetrachloride in gallons, and it gives the density in grams per milliliter. So this is kind of a quick, well, not a quick, but we're going to take our volume, and we're going to use our density to get to mass. So the problem is that our volume is in gallons, but notice the problem goes ahead and tells you how we can get from gallons to liters. The equivalency statement given in italics at the end of the problem. In this class, I don't give you information, well, usually, I don't give you information that you wouldn't need to use. So if there's a number there, you're probably going to need to use it. So get used to taking things like 1 gallon is approximately equal to 3.785 liters, making that to equivalency statement that you can use as a tool. So with that in mind, then we can use that equivalency statement, take a 3.785 liters over 1 gallon, so our gallons will cancel. We're at liters now, and we want to use density, which is grams per milliliter. So we're going to have to go from liters to milliliters with another term. So now our liters will cancel. Now we have milliliters. We're ready to stick in the density, which is 1.604 grams per 1 milliliter. So when you string them up and cancel terms, the only term we have left is grams. The only units we have left is grams, which is great. One more look at how to round it. Looks like we're rounding according to what, 4 significant figures? So even though this is what our calculator displayed, we start from left to right, keeping digits, 1, 2, 3, 4. So we're gonna have to truncate it here between the 9 and the 0. And if you're like me, like, oh, I hate those 9s. But anyway, it's no problem. We're gonna go ahead and, since it's a 9, round that 0 up to a 1. So then that's why the answer is like that. You can either do it like this in regular notation or pack it up in scientific notation.
Why do we have a 0 with trailing 0 if we're...
For Sig Figs? Because this is kind of giving it magnitude. This needs to show that this number out here is in the what, 10,000s place. If we didn't put that 0, this number would be in the 1,000s place. And we need to show that no, that's in the 10,000s, that's in the 1,000s. So this 0 is not significant, but it's important. Okay, it shows magnitude. So either regular or packed up in scientific notation would be great. Yes, there was one of these on there. In this one, you had to be able to kind of do the whole cube thing. And notice when I say cube thing, I'm going to talk you through the problem, but the cube thing I kind of left down here as writing 1 inch over 2.54 centimeters 3 times. I avoided the cube thing. I think I have issues with my calculator raising it too high, but anyway. So in this case, it says what is the volume of 1.50 liters in units of inches cubed? So I'm going to start with the 1.50 liters, and I want to get to inches cubed. And I know that if I can get from liters to milliliters, I have this kind of thing going for me. 1 milliliter is equal to 1 centimeter cubed. So that's my first term to get to milliliters. Liters cancel, I'm left with milliliters. Now to get to inches cubed, and then I go from milliliters to centimeters cubed. Now when I'm at centimeters cubed, I recognize that I know that just in one dimension, 2.54 centimeters is equal to 1 inch, but I have to do it 3 times to get my inches cubed, to get my centimeters cubed to cancel. If you let things cancel here, everything cancels except for the 3 units of inches, which is inches cubed. So we got to round it according to 3 Sig Figs, so it looks like we're going to truncate it right here. So we're going to keep it'll be 91.5 units or inches cubed. Now on to the last page. Right? Okay. So for this one of the things that I'm encouraging you to do, and I saw a lot of this, is unpacking. That 18.5%, what does that mean? Well, if you read the problem a few times, you're like, well, it's a sugar solution, so 18.5% must mean 18.5 grams of sugar or sucrose in 100 grams of the mixture. In this case, the mixture is still solution. So if you unpack that, the other thing is I said things that, in this case, it's in italics again at the end of the problem. You're going to need to use that in the problem. So it says 1 pound is approximately equal to 453.6 grams. So go ahead and write that equivalency statement. Doodle, I call it doodling, kind of, before you work the problem. Once you get that down, kind of at the top of the problem, then you're ready to rock and roll. So then the thing that I didn't use, right, doodle, was the 2.5 pounds. So that's going to be my first term, 2.5 pounds. And then I'll look back up and I'm like, well, what do I know about pounds? Well, I know this about pounds. I can get from pounds to grams using this. So it kind of draws you, if you doodle, you're like, oh, well, I'm ready to go ahead and use this now, the pounds to grams. So I'll put 453.6 grams of sucrose and 1 pound of sucrose. So pounds of sucrose cancel, now I have grams of sucrose. Again, what do you do next? Well, if you look at your doodle, you're like, well, what do I have grams of sucrose? Well, I unpacked my weight percent. I've got grams of sucrose right there, but I need to flip it. So there's where I'm going to go ahead in my next term, I'm going to put 100 grams of solution over 18.5 grams of sucrose. Now my grams of sucrose cancel. I'm left with grams of solution, which is awesome. Notice actually, as I was going over the test, I didn't even say, what are you trying to get to? I just kind of started saying, well, here's the weight percent unpacked, here's the equivalency statement given, here's my first term. Okay, so, but what we're after was the mass of solution that would contain 2.50 pounds of sucrose. So rounding it to 3 Sig Figs, I'm going to truncate it right here. And since this is a 9, I'm going to round that 2 up to a 3, but I'm going to still have to go ahead and still include this 0 here to show that the right magnitude of things. This would be 613, but I want 6,130. But I don't put a decimal there because that 0 is not significant. All right, so the last one, dun dun dun. Yes, I took 6 points off because I thought this one was probably a little challenging. We'll be talking more about atoms, cute little atoms, and the fact that they're very small, and we use big numbers to represent the number of atoms because they're so small. But again, if you unpack the information in the problem, things kind of fall into place for you, I think. So the density is given. Remember, 7.86 G/cm cubed means this, 7.86 grams per 1 centimeter cubed. The last statement said, or I guess the next sentence says 1 gram contains approximately 1.08 times 10 to the 22nd iron atoms. Okay, so I'm going like this, so that's my equivalency statement. I can't do this on the video, I know. But I would if I could. Okay. So that actually is an equivalency statement we're going to use as a conversion factor. So it says, what volume of iron, so I'm going to try to get to volume, would contain 2.50 times 10 to the 25th cute little iron atoms. So this number, 2.50 times 10 to the 25th, Fe atoms, is actually the term I'm going to start with over 1. If I do that and I've doodled up above, I'm like, what can I do next? Well, I know that the problem told me this relationship between iron atoms and grams. So that's going to be my next term. Okay, of course I want iron atoms to cancel, so I'll put those units in the bottom, 1 gram on top. Then I look back up and I'm like, what else do I have? I've got grams now. Now I can use the density. I'm going to have to use the flipped version of the density though, right? 1 centimeter cubed over 7.86 grams. So now grams cancel. The units we have are centimeters cubed. Taking one look at it, I've got 3 Sig Figs in this coefficient. And I've got 3 Sig Figs here. And so I need to round to 3 Sig Figs. Since this is a 5, I'm going to round that 4 up to a 5. So 295 centimeters cubed would be the answer. So that's that in a nutshell. And yeah, I'll rescan it in so I can get that one page. Thanks for pointing that out.